Rotations. Our objectives for this screencast are to rotate a figure given a center of rotation, an angle measure, and a direction, and also to describe the rotation given a pre-image and its image. First, let's talk about what a rotation is. A rotation is a turning of a figure around a fixed point. Each pair of corresponding points is the same distance from the fixed point at the same angle, which is just a fancy way of saying we're looking at a rigid transformation. All angle measures are preserved, all side lengths are preserved, and essentially it's the same shape, same size, different position. And we move the position by turning rather than reflecting or shifting. So, some questions that we might have had is, what is the center of rotation? The center of rotation is that fixed point that we do our turning or spinning. So we have our figure. We are going to rotate that figure. And we get our image, which has been turned from our original pre-image. When we're talking about how we're going to rotate, sometimes people refer to this as clockwise or counterclockwise. Clockwise is moving as the clock does. Counterclockwise would be in the opposite direction of how a clock moves. What we're going to look at is how does that apply when we're looking at a shape on a coordinate plane. So when we're looking at clockwise, we would move 90 degrees, and we would move 90 degrees in that clockwise rotation. Another example might be 180 degrees. When we're looking at rotations and in future years of math, you're going to learn that you can have angle measures that are smaller than an acute angle or larger than an obtuse angle. So, for example, if we wanted to go 270 degrees, we would be moving the original 180 plus an additional 90. So that's what a rotation of 270 degrees might look like. Now let's consider counterclockwise. Again, we're looking at a 90 degree angle, 180 degree. Moving beyond that 180 degree, we might be looking at a 270. Also, as math people tend to think counterclockwise when we're looking at our angles, what happens if we go in the reverse direction, but counterclockwise? We're going to start to see some negative angle measures also. So angle measures that are less than 0 and angle measures that are bigger than 180 in your future math classes. Usually in geometry, we'll stick to clockwise or counterclockwise 90 degrees. So how would we rotate the figure 90 degrees counterclockwise about the origin? So there's my origin, there is my pre-image, and since we want a 90 degree rotation, we need to translate A 90 degrees, or we're looking for a segment that's perpendicular. So as I consider my slope, I went up 1, right 2 from the origin to get to point A. That gives us a slope of 1/2. A perpendicular slope would be opposite reciprocal. So we would need a line or a line segment that has a slope of -2. And since we want to move it counterclockwise about the origin, we're really going to be looking for a point in that second quadrant only. Now, to maintain that distance, because the distances need to be preserved, I have to somehow go up 1, right 2, or an equivalent motion to get to my new point. So I'm going to go left 1, up 2. And now my red segment and my blue segment they are perpendicular. It's 90 degrees. And that's the position of my A prime. This seems kind of complicated or long, so let's kind of fast forward through finding the rest of the points. So what's important to know is that all of those segments from the origin to each of those endpoints are forming a right angle with the segments from the origin to those images. And if we take a look at our coordinates, what we started with, and now let's take a look at the coordinates of our image. Let's see, A prime was at -1, 2. B went from -3 to 4. C prime is -4, 5. D prime is -5, 3. Those numbers seem to be familiar. I seem to be using the same numbers over again, and I think there might be a pattern. So why don't you think about it for a minute, and what do you think the pattern is from the pre-image to the image when we do a 90-degree counterclockwise rotation about the origin? So it looks like our X and our Y got flipped, but the original Y coordinate became negative. Seeing it in terms of X's and Y's can sometimes be confusing, so another way that you might see it is in terms of A and B. This way we're not really focusing on the old X becomes the new Y, but more, the position switching and one of them becoming negative. Now, let's take a look at our next topic of rotating a figure 90 degrees clockwise about the origin. So we're going to start off pretty much the same way, realizing that I'm going to need perpendicular segments. We went up 1, right 2, slope of 1/2. So that A prime, that image of A, is going to have to lie somewhere on that purple line. But since we're moving 90 degrees clockwise, we're just going to be focusing on that fourth quadrant. I'm going to maintain my distance by doing a relationship of a 1 and a 2. And in this case, it's right 1, down 2 to make sure that I'm on that purple line. And that's where I expect point A prime to be. That's where I expect that image to be. And that's going to be my A prime. So let's fast forward through the rest of the points. And now, let's take a look at those original coordinates from our pre-image and see if we can figure out what the pattern might be for a 90-degree clockwise about the origin. So, A prime was 1, -2. B prime is at 3, -4. C prime is at 4, -5. What do you think the coordinates for D prime would be? And what pattern do you think we've established? So for our 90-degree clockwise about the origin, again, our X and our Y's flip places, they exchange places, but this time it's our X that's the opposite. And again, you will most likely see it in terms of A's and B's rather than X's and Y's. The last type of rotation I'd like to look at is the one for 180 degrees about the origin. So looking at our pre-image, again, we're looking at a distance of up 1, right 2 with a slope of 1/2, but we want this to be a 180-degree angle. So I'm really focusing on a line that passes through the origin that also has a slope of 1/2. And since we are focused on translating it 180 degrees, we're just going to focus in on that third quadrant. Now I need to maintain that distance of up 1, right 2, and making sure that that point stays on the purple line. That's down 1, left 2. So our A prime would go there. Let's translate the rest of our, let's rotate the rest of our points and see if we can figure out a pattern. Taking a look, A prime, -2, -1, B prime, -4, -3, C prime, -5, -4. Are you noticing a pattern? What do you think the coordinates of D should be? What pattern have you observed? When we're rotating 180 degrees about the origin, each of our terms become the opposite. And again, you might see it in terms of A and B, but both of those essentially mean the same thing. So let's see if we can identify the rotation. In our first figure, we have our image and our pre-image. And it appears that we are moving in a clockwise rotation, and I would imagine it would be a 90-degree rotation. So we are rotating 90 degrees clockwise about the origin. Let's look at our next example. Trying to imagine the lines as I connect the image to the pre-image. It looks like those are all 180 degree angles, so we're rotating 180 degrees about the origin. And it does not matter direction. 180 degrees, clockwise or counterclockwise, will result in the same picture. So the correct answer would be rotate 180 degrees about the origin. So in the screencast, hopefully you can rotate a figure given a center of rotation, an angle measure, and a direction, and also describe the rotation given its pre-image and image.